Hello, good morning everyone. My last lecture was derivation of Kel- Kelvin-Gordon equation for a free particle. In a last lecture, I introduced the relativistic quantum mechanics. So in this is the Kelvin-Gordon equation for a free particle. Today we are going to discuss about probability and current densities of a wave function. Okay. See, this is the Kelvin-Gordon equation for a free particle. So, what do you know about the probability density? Probability density. So, psi star psi, which tells the probability density. Current density is represented by J, which is equal to minus IH cross psi into del psi star minus psi star del into psi. So this is the current density. So we are going to derive the probability and the current densities in relativistic quantum mechanics domain. Okay, this is the Kelvin-Gordon equation. So now multiply the psi star, means complex conjugate of a wave function from the left we get. So multiply the psi star psi from the left, then the equation will be psi star psi. Equation will become like this. Just multiply it, complex conjugate of wave function from the left side. Okay, then taking the complex conjugate of the equation 1 and multiply the psi from the right we have. So ఇప్పుడు మీరు ఏం చేస్తారు అంటే టేక్ ది కాంప్లెక్స్ కాంజుగేట్ ఏమవుతుంది, del square minus 1 by c square dou square by dou t square psi star, which is equal to m naught square c square divided by h cross square psi star. Okay, now multiply the psi from the right side, then we get multiply by psi, here psi. Okay, then subtract this equation 3, then you get the equation like this. This is not a multiply, this is the psi star. Okay, subtract the equation 3. See, this is the equation 3, which is equation 3. Subtract the equation 3 from the equation 1, from equation 2, subtract the equation 3 from the equation 2, then we get, see, this left hand hand side terms are equal, then when we have done the subtraction, these two terms are same, so this going to be 0. Okay, now see, first consider this equation psi star psi. So psi star del square psi minus psi star 1 by c square dou square psi by dou t square. Okay, like that you will get this equation. So we got this equation. So then rearrange the terms, then you get the equation like this. Okay. So rearrange the terms, take the 1 by c square as a common, then you get the equation like this. We can take it out the delta from this equation. So this expression will become like this. So now multiply throughout the h cross divided by 2I m. We obtained, now multiply the throughout by h cross by 2I m. We obtain del, then this inner bracket which is equal to s, this inner bracket will be equal to p. So here S is defined as the current density. Here P is defined as the probability density. Okay. This equation is called a equation of continuity and is invariant with respect to Lorentz transformation. Okay. So I have explained what is the Lorentz transformation in electrodynamics. So I'm not going to discuss it about it now. So current density S of R comma T has same form as for the non-realistic case. So non-realistic case la ela undo realistic case la kuda alage undi. Consider the probability density. Actually the probability density is like this, psi star psi in the non-realistic case, but in the realistic case it looks like this. So multiply minus IH cross on both sides. Take the minus IH cross. Multiply I on numerator by the denominator, then you get minus I. So minus I you have, so minus plus I. Okay, then so this is going to be the energy times, and this is the energy operator. This is going to be energy operator. So energy times E psi star psi plus psi star E psi. Okay. So here H cross is not there. It's a wrong printed. So here H cross is not there. Here is 1 is there. Okay. So this is going to be a E psi star psi, because E is an operator, so dou by dou t. Okay, by E has a uh, has energy of a particle may be positive or negative. If energy of a particle is positive, then the probability density will become a positive quantity, and accordingly probability density will be positive or negative. If the energy is positive or negative, then the probability density will be also a positive or negative. Previous assumption requires that probability density should also be positive. Previous assumption requires the probability density is also a positive. The probability and V of proposed P of r comma t multiplied the charge of the particle will be interpreted as the charge density. So probability density and multiply the charge of a particle is interpreted as the charge density. Okay, which can be positive as well as negative, as long as it is real length work, that's positive or negative. So okay, so yesterday we have discussed about so current density, which is this is charge density. When the probability density is multiplied by the charge of a particle, then it will become as the charge density. So remember that. Okay. Thank you.